Alright, what's up everyone? This is LeetCode 704 binary search. I've done this problem in Python, but now we're doing it in C++, so yeah, we're basically just implementing a binary search. You kind of get the hint by the title of this problem, as well as them telling you you have to write your algorithm in O log n. So yeah, you're basically just given a sorted input array of integers, and you're given a target, and you basically have to find if this target exists in this array. Using O log n runtime complexity, so that would be binary search. Now, if you don't know what binary search is, simplest way to explain it is like we basically just set a left pointer at the start of the array, a right pointer at the end of the array, and we use that to compute the midpoint in the array. And then basically we check, okay, is target less than this midpoint or greater than this midpoint or equal to this midpoint? Actually the midpoint would be 3 here. So 9 is greater than 3, so we set our left pointer 1 to the right. We don't actually set the pointer at the 3 because this 3 is not actually equal to target, so we don't need to set the pointer here or anything, right? This 3 is irrelevant to us, just like anything to the left of this 3 is irrelevant to us. So we set the left pointer actually 1 to the right. Likewise, let's say our target was some number that's less than 3. Our right pointer wouldn't be set to 3, but it'd be set to 1 to the left of this 3. And basically, when we shift these pointers over, we compute the midpoint again, and we keep doing that until we either find target or we don't. If we don't find target, we just return -1 after we go through the entire list. And we know we go through the entire list when the left pointer and the right pointer are at the same spot, and we check again. And when we check again that final time, if that specific number isn't equal to target, then we just return -1. It'll make more sense when you see the code. Now, if we compute a midpoint or we keep doing this algorithm and we encounter a target, then we just return the index of wherever this target's at, okay? So let's set the pointers, right? Left pointer, this is the right pointer. That's size. We want the last index, so we're gonna do -1. We're gonna say while left is less than or equal to the right, right? And we're gonna say the midpoint is equal to left plus right divided by 2. We don't want to write it like this though, because technically if we add left to the right, we can, in certain edge cases, we can have an overflow error. So we can actually write this like this. We can say left plus right minus left divided by 2. And I'll come back to this in a bit. Let me comment this and just say can get overflow when adding two big numbers. Okay, so we calculate the midpoint. Now let's check if the target is less than, greater than, or equal to the midpoint. So if target is greater than the midpoint, that would be a case, that would be a case where we would want to, so if we can hit the midpoint and target is greater than the midpoint, we shift the left pointer over. Left is equal to mid plus 1. Now else if the target is less than the midpoint, that would be, so if target is less than the midpoint, we shift the, if target is less than the midpoint, we shift the right pointer over. So it would be this. Else, this is the case where the midpoint is equal to target. So in that case, we can just return mid, okay? Now if we exit this while loop and we never return mid, that means that target was not found in the actual array. So that would be a case where we return -1. Okay, pretty simple algorithm. If it's a bit hard for you, it's probably just your first time seeing binary search, but you're going to see this problem over and over as you move on to harder problems. But it's pretty easy to grasp. Maybe just your first time it's a little bit hard to understand, but it'll be easier once you practice this problem more and you see it in other places. But anyways, I want to go back to this here. Why we do this, okay? What are we doing when we do this? So, because we're finding the midpoint, right? Well, we're writing this two different ways. So I'm going to go to an illustration here. Okay. Now, usually when we add left to the right, we add this left to this right, and we divide it by 2, and we get the midpoint here, right? But that can, when we add this left to this right, if we have two big integers, we can have an overflow. So we don't want to do left plus right. We would do left plus, and then we would do right minus left divided by 2. And what this does is when you do right minus left, you get this divided by 2, and you get this here. So when we do left plus right minus left divided by 2, see how when we add this to this, we kind of get the same midpoint without having to actually add these two big numbers together. So we can kind of avoid overflow by doing that. I can just play this right here.
Here, right? And then we add the original L back again, sort of here, right? That's the restrictions on integers. So what would be a better way of doing it? What we were originally doing was L plus R divided by 2. So if you had an L that was here, like this, and a bigger R, because your R is over on the right-hand side over here, what you would be doing is putting this here, adding them together, and taking the midpoint, which would be somewhere sort of here, right? That's kind of the idea. That's your average.
But yeah, if you put that there, it'd probably run off the end.
Right, runs off the end of the screen, and we've got our overflow, and then we're all way over here on the, yeah, exactly. Right, so, you know, the paper works, we should stick with it. What we're going to do instead is we're going to do R minus L, right, R minus L. So what would that be? That would be the difference between R minus L here. I could probably draw it over here.
So then what you do is what, half of that and then add it to the L?
Exactly, right? So we divide this by 2 to get this bit here, right? And then we add the original L back again. So this is R minus L over 2, and then we add back L, right? I'm not sure if drawing it out like this worked, but hopefully that makes sense.
So it's a slightly more complicated sum, but hopefully it keeps us in bounds,
yeah.
right?
So what we...
Okay, so that's basically what we're doing, okay? Shout out to Computer File for drawing that out. But yeah, I just wanted to show that and go into detail, because sometimes people who go over this problem kind of just gloss over how this is different than this. So I just kind of wanted to show that illustration so you kind of understand how this is different than this and why this is avoiding overflow, whereas this is not. And overflow isn't a problem in like certain languages like Python, but it is in C++, right? Because you can overflow integers. So yeah, I hope this helped. And let me submit, actually. I think I did submit, it worked, but yeah. Anyways, I hope this helped, and I'll see you in the next one.